Good afternoon once again, guys. We are meeting Power Machines N5. So I'm also addressing the same question or the same topic of steam plant. Now, use steam tables to determine the following: sensible heat, latent heat, as well as saturation temperature. Our steam pressure is given as 1035. So we need to make use of our steam table. So on the first part, they want us to look for our sensible heat. So to determine our sensible heat, we need, we say HF at 1035. Which is the pressure which is given. So let's go to our steam table to check if we have 1035. Now, if you check on the steam table, you see now that there is no 1035. So such a question like that, we have no choice but to resolve it by means of interpolation. So these three, they are going to be resolved by means of interpolation. So we are going to say, therefore, HF at 1035, you see now that it falls, it was supposed to be between 1000 and 1050. If you check on our steam table, that's where 1035 was supposed to be. So we are going, therefore, to say we need to get our HF or HF at low pressure plus the given pressure. What's our given pressure minus our low pressure over our higher pressure minus our low pressure times our HF at higher pressure minus our HF at low pressure. So that's how we resolve a question like this by means of interpolation. What am I saying when I'm saying at low pressure? We are simply saying you need to go into a steam table, our lower pressure, because we don't have 1035, but 1035 on the lower side, it is closer to 1000 kilopascal. Plus, what's our given pressure? Our given pressure is 1035. Our lower pressure is 1000 over our higher pressure, it's 1050. Yes, it's 1050 minus our low pressure, which is 1000, times our HF at higher pressure, we say it is now 1050, minus our HF at lower pressure, which is 1000. That's how we resolve a question of this nature. So if you go to your steam table now at 1000, let's get our HF. Our HF here is 763. So it's 763 plus, here we just get the difference, which becomes 35 over 50 times our HF at 1050. At 1050, our HF is 772. So it's 772 minus our HF at 1000, which is 763. From there, we substitute, so we have 763 plus 35 over 50 times 772 minus 763. I'm getting 763. Okay, if there is no mistake, let me check if I punch correctly. 763 plus 35 divided by 50 times 772 minus 763. So I'm getting my answer is 769.3 kilojoules per kg. So this becomes our sensible heat. Now on question number B, they want us to determine the latent heat. So there's no need for you to rewrite the same thing here, because already here we know which variables are going to be interpolating in between. So we just need to go to HFG at what? 1000. If you go to HFG at 1000 kilopascal, here I'm getting 2014 plus, here it doesn't change, it becomes 35 divided by 50. And then we need our HFG at 1050, which I'm getting here is 2006 minus 2014. That's how we solve it. So from there we substitute, which is 2014 plus 35 divided by 50 times 2006 minus 2014. I'm getting 2008.4 kilojoules per kg. That's how we get our latent heat. And lastly, saturation temperature, which is our C. Our TS, we do the same thing what we have done on A and B. Now, what is only going to change now? We are no longer looking for HF or HFG. We are looking for our TS at 1000. If you go to your steam table, our TS at lower temperature, we are getting 179.9 plus 35 over 50. This one, it does not change. It remains the same. It doesn't change. Into our HF, or rather our TS at 1050, which I'm getting as 182 minus 179.9. So let's see what I'm getting there. 179.9 plus 35 divided by 50 times 182 minus 179.9. I'm getting, my answer is 181.37 degrees Celsius. So that's how we solve a problem of this nature. That's how we solve it. Thank you so much.